Daily Space for today, August 1st, 2019. I'm your host, Dr. Pamela Gay, and I am here to put science in your brains. Today we have a whole lot of random things to bring up. The first thing I would like to let you know is Bennu Mappers is still going. The first thing I would like to let you know is Bennu Mappers is still going, and we are currently looking into ways to reward those of you who have gone above and beyond with a little something special that you can hold in your hands. Everyone who has ever mapped anything with Bennu Mappers, even if it's just one image, is going to be getting a digital certificate thanking you for all your efforts. But for those of you who've done 50 images, 100 images, 1,000 images, and there are 4 of you who have done more than 1,000 images, for you, we're looking into, well, just what we can send you. And by we, I mean I was talking with the mission team this morning. So if you're thinking, hey, I did 45 images, that's enough, go do 5 more. You might appreciate the time well spent. And we're also looking into things like how in the future can CosmoQuest potentially be involved in, well, naming features. And again, we're going to be turning to our super users as our first line of engagement as we continue to explore this rubble pile of an asteroid. Now, there are lots of different nonprofits out there finding and defining new ways to explore our solar system. And one of those groups is the Planetary Society out in Pasadena. And they have been working to bring, well, a new way of orbiting. And that way is Lightsails. There was a fabulous Arthur C. Clarke short story decades ago that talked about yachts light sailing on solar wind. Well, we don't have yachts yet, but we do have a little spacecraft, Lightsail 2, that, well, it was loosed into orbit on July 12th into a nice little circular orbit, and then on July 23rd, it successfully deployed its Lightsail, and in the days since then, it has been working to change its orbit from that circular orbit into a systematically more and more elliptical orbit that on one side is, well, stretching further and further away from the Earth, while on the other side, the orbit is getting closer and closer to the Earth. It's going to continue to alter its orbit up until the point where its closest approach to the Earth is actually starting to dip it into the Earth's atmosphere, so that the drag from the atmosphere is greater than, well, the acceleration that it's able to achieve by interacting with the sunlight. So until then, they're going to continue monitoring just what's possible and continuing to explore the reality of this new way of getting around in low Earth orbit. Now, moving a little further afield, from spacecraft development to spacecraft discoveries, we have our second story of the week to come to us from the TESS mission. Just like we had on Tuesday, today's round of press releases brings us a trio of releases announcing a trio of planets. In an announcement that was released by the Carnegie Institute, Cornell University, and NASA Goddard, a team of scientists shared that the red dwarf star GJ357 has been discovered to have 3 planets, including one in that little star's habitable zone. This system is just 31 light years away from Earth, making it one of the closest stars to be discovered to have planets. And this system is different from anything we have in our solar system. The innermost planet is a hot Earth. It's 22% larger than Earth and orbits that star every 3.9 days. Farther out, we have GJ357c. It has a 9.1 day orbit and is another super Earth at 3.4 Earth masses. The outermost world. It's more like Mercury with a 55.7 day orbit and is 6.1 Earth masses. And I don't know if we classify this as a super Earth, a sub-Neptune, and we'll have a better idea when James Webb Space Telescope, if James Webb Space Telescope ever launches and is able to look at this world and is able to look and see just what its atmosphere is composed of. This world is in the outermost areas of its star's habitable zone. If it doesn't have an atmosphere, if it's just hanging out going, hi, I'm a naked rock, it's going to have an equilibrium temperature that's minus 64 Fahrenheit, minus 53 Celsius, which isn't really conducive to life. But if it has the right kind of a thick atmosphere with the right combination of greenhouse gases, it's possible this world is warm enough to have liquid oceans and potentially even life. Now, if you're wondering why TESS is finding world after world around red dwarf stars when we didn't really see that with Kepler, it's because TESS is searching the closest stars, and since red dwarfs are the most common kind of star, they're the bulk of what TESS is going to be looking at. When we look up, what we see the majority of is bright stars, because bright stars can be seen at much larger distances, allowing us to see a much larger volume of space. Kepler, which looked at a single field on the sky and essentially looked at a smaller volume nearby and a larger and larger volume of space as it looked further and further out, it majority saw brighter stars. These two different types of searches are going to turn up totally different kinds of solar systems. So yeah, really bright stars are rare, and TESS is going to find all the red dwarf systems hanging out nearby. Now, one of the hardest kinds of stars to find is a metal-poor second-generation star. As far as we understand it, the first generation of stars formed in our universe was made of hydrogen and helium with just a touch of lithium. Basically, this first generation of stars, they were made with the stuff that was left over from the Big Bang. These stars were significantly bigger from what we have today, as far as we understand it from our models. And they lived and died quickly and just aren't out there for us to find. That second generation of stars, though, they were made mostly of the same stuff, but were enriched with just a touch of heavier elements that changed how they evolved. These heavier elements allow stars to radiate away light in a very different way that changes their atmospheric properties. And these stars are able to live much longer. And in the case of the smallest of these second generation of stars, they're still here to be found today. The trick is finding these stars in the vast diversity of stars that have been forming in the past 13 billion years. In a new paper released in the monthly notices of the Royal Astronomical Society, a team led by Thomas Nordlander of the Australian National Observatory, or rather the Australian National University, has announced the discovery of a star that has 1.5 million times less iron than our sun. Now, iron is generally used as a tracer element to indicate just how many heavy atoms are in a star. This particular diagnostic, in this case, well, that tiny amount of iron combined with the star's evolved state tells us that this star that they found is likely one of those hard to find second generation stars. In fact, they think that it was made from the materials from a single supernova explosion. And that material was mixed with an otherwise pure cloud of primordial hydrogen and helium and just a touch of lithium. It likely formed in the first few 100 million years of our universe. And that's just plain kind of awesome. And when we find stars like this, that tells us that our understanding of how stars formed in the early universe and how they lived and died is probably true. We just need to find more stars like this to continue constraining our models, which so far, are turning out, in this case, to be completely right. Now, today's final story isn't exactly one that's very scientific, but it is one that taught me something new about astronomy nomenclature. Today is the first day of August, and it's also a new moon. Since August has 30 days, this means the moon will have time to make it all the way around the Earth relative to the sun before we enter September. The second new moon of the month, I learned today, is called a black moon and is the sibling to a blue moon, which is the second full moon of the month. The black moon will be occurring in the United States Labor Day weekend. That's just a regular weekend to everyone else out there. And I encourage all of you to go out, look up, and be amused by this not entirely scientific fact that is nonetheless astronomy related. And sometimes amusement is the best we can ask for. So, 2 new moons for the month of August. And if you look at this calendar, you'll notice no blue moons for 2019. And that's really all I've got for today. So I will now answer all your questions. And I'd ask you to please at CosmoQuestX while you type them in. And while you're typing those questions in, I'm going to remind you that the Daily Space comes to you most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific, that's 6 p.m. London time. We also have a show on Sundays, the Sunday Science Hour, brought to you by our own Annie Wilson. When we are not bringing you the Daily Space or the Sunday Science Hour, we bring you a whole variety of, well, in-the-moment events, whether it be the launch or landing of a spacecraft or a new science result, or sometimes, well, we'll just pop online to share with you what we're doing. And Annie has been hosting a variety of Let's Hate Map Bennu together, Twitch streaming sessions. So give us a follow. Follows are free, and find out whenever we go live. CosmoQuest is a production of the Planetary Science Institute, a 501c3 nonprofit. We are here to explore our solar system and beyond. We are brought to you by you. We're a 501c3 nonprofit, which means that your bits, your donations, your subs here on Twitch, and your patronage over at patreon.com/CosmoQuestX, all those things are tax deductible where the law allows. So thank you for supporting us. And if you can't support us monetarily, it's okay. We get that. We're scientists. It's not like we're rich. We know that often you want to support projects and you just can't do it with $1. Well, you can support us also by doing science, by helping us out in mapping, Bennu right now. And so please help us get the word out. This little rock orbiting the sun, well, actually this rubble pile of millions of rocks orbiting the sun as they gravitationally glom onto one another. It needs you to help us map it out and find all the boulders, all the rocks, and hopefully find the safe place to land and explore. And if you are one of the many lucky people who got handed one of the images that turned out to be an ideal landing site, we'll be notifying you when the team announces later this month exactly where the spacecraft is likely to go in and grab its soil samples. Okay, I am now going to scroll back to the beginning of the chat and see exactly what questions have come in that I can answer. Scrolling. Yeah, I know. I started out muted. Sorry about that. Oh, I'm sorry my volume is a bit low. I must have bumped a setting. I'll try and get that fixed for tomorrow. I hope you're enjoying the Planetarium Conference, Refs Matt. Please tell everyone about us. Okay, Guido says that the volume seems to be good. Yay! Hello, fellow hoodlum. We haven't seen you in a while. Or at least I haven't seen you in a while. Scrolling. Kerbal thinks they've done 30 images. That is amazing. And thank you, Guido. You may think that you've been terrible, but every image helps. Every image helps. Let's see. Looking for questions. So Larry is asking, has TESS discovered new red dwarf stars, not just planets? No. So what TESS is doing is it's looking at known red dwarf stars that have been found through any of a myriad of other surveys. And it's watching these red dwarfs to see if it detects the dips in light that are indicative of a planet passing between us and that star. We do care about lithium, Larry. We do care about lithium. I think thank you for the bits, Trekker Kev. Thank you. I can show you quiet, happy, sleeping dogs. I think I can at least. Yeah, there are the happy dogs. Whoa, that does not go as planned. There we go. Dogs, sleeping dogs. I'm gonna let the sleeping dogs lie. So I see the comment that looks like a ghost. There's multiple images today that all could be said to look like a ghost. So we have switching views. Oh, my computer is not being happy today. So we have the Lightsail image that looks like a bad Halloween ghost. If it will switch, come on, you can show it. There we go. And then we also have the star. And this is actually an illustration of how they think the universe looked when the star was forming. So Larry, I think we are still calling these extremely metal poor stars Pop 3 stars. And then there's the original stars. I think that's what they're doing for nomenclature at this point. So Pop 1 is the most current population. Pop 2 are normal everyday metal poor stars. Pop 3 are the oldest, most metal poor stars that formed out of the debris of the first generation of stars. And yes, I do think those numbers run backwards. So Stormer Joe is asking, have they started identifying places to land on Bennu from the images completed? They have. And I think that's all I'm allowed to say. Looking to see. So Henny asks, can any solid planets form around a star with so little metal? We don't think so. As far as we know, you only really start to get planets when you have metal-rich population 1 stars. So far, no planets have been found in population 2 globular clusters, or in the more metal-poor field stars. You have to have stuff in order to form planets. So this is what we know so far. Let's see what else is in here. So Veronica Cure is asking, what generation is our sun? There are people who think they've started to figure that out, like figure out how many generations of supernova went into our sun. I don't know what the latest consensus is. It's a metal-rich population 1 star, which means multiple generations of dead stars went into its formation. Other than multiple generations, I'm not exactly sure. Thank you for the follow, Gotzavunk. Trillion H2O asks, are all the other planetary systems we've discovered so far in their own ecliptic around their own star? Yes, but that's because of how the experiments are defined. Currently, the only 2 ways that we can find, or the only 3 ways that we can find planets around other stars are if those planets pass in front of that star or pass in the plane that is aligned with us near their star And we're able to see either the gravitational movement of the star to and fro as that planet goes around. We're able to see that planet eclipse the star, or in the case of I guess with gravitational microlensing, we don't know the orientation at all. So with microlensing, if we see a star system pass in front of a background star, we'll sometimes see a brightening of that background star as the gravity from the planet and that star bends more of the background star's light towards us. So that one, we don't know anything about the orientation. And in the other two cases, we're seeing the movement of the star to and fro. Now, with Gaia, I believe we're going to begin to be able to see planetary systems that are in the plane of the sky, and we can see the central star moving relative to background stars, side to side, up and down, as things go around it in the plane of the sky. I don't remember if we've found any stars that show that kind of motion and show planets that way. Now, because of the way eclipsing stars work, or eclipsing planets work, we're only going to find things where all the planets are in the same plane and are all able to eclipse that central star. So I think just because of how things are set up, that's the only way we're going to find things right now. So Larry Weird is asking, what star was considered the first Pop 3? Oh, I don't remember its name, but I do remember its discoverer. One of the discoverers was Dr. Timothy Beers, and I believe it was found by the Sloan Digital Sky Survey. I could be wrong. I know I'm not wrong on the person, I just could be wrong on which survey it was. It was a number of years ago. We first started finding these things probably a decade ago, maybe more than that at this point. Fenring asks, is the generation number also logarithmic as well as inverse? Just kidding, really, sorry. You know, it's astronomy. It seems like that's entirely possible, but no, we just sort of group things up by how much metal they have in them. Larry asks, does stellar generation have a logarithm curve or an exponential maybe? I wouldn't even know how to answer that. And part of it is there's this real bias where we're only able to see the longest lived stars from earlier generations. So when we look at globular clusters, for instance, we're only seeing lower mass stars still existing. All the highest massed ones already went supernova and became neutron stars or expanded into planetary nebula and white dwarfs. So over time, all the larger stars in old systems go away, leaving only part of that generation behind. But what I don't know is how the rate of star formation has changed over time. So I can't tell you if there were more stars forming or fewer stars forming in those older generations that would lead to a bias in what's left. I don't know is the answer, but I can tell you the things that factor in, which is kind of useless. Anyways. So Henny's Ververb is asking, is it hard to tell generation because of supernova, kilonova contamination? So the number of stars that have gone supernova in a given region will change the amount of metal that is available. So this means that one of the confusions is you can have rare but existing clouds of almost pristine gas left over from the formation of the universe that are going to form modern day population 2 stars. And you can also have places where early in the universe a whole bunch of supernova went off rapid fire and you have old population 1 stars. So we can tell you what generation a star is for the gas it formed from, but it's all very confusing and complicated. I don't know if this information helped. I definitely need to do an Astronomy Cast update on this, and there are existing, as Veronica Kier is pointing out, there are existing Astronomy Cast shows on this information. There is so much to know about it. Stellar astronomy is seen as boring by a lot of people, but the reality is stars are the building blocks of everything else. And they are extremely complicated, and there's a whole lot of details to try and uncover. But I think that sums up everything for today. And I think that means it's time for me to go get lunch. So I'm just going to remind you one more time that this is the Daily Space. And we come to you most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific. That's 6 p.m. London time. We are brought to you by the Planetary Science Institute. Dang it. We are brought to you by the Planetary Science Institute, a 501c3 dedicated to exploring our solar system and beyond. We are able to bring you this show thanks to your generous contributions. Thank you for everything you give, whether it be dollars or clicks, by helping us map out worlds in our solar system. So that's it. That's all I've got. Yeah, I am now going to figure out how to roll the credits. And if anyone has anyone that they can suggest that we raid, I am open to any and all suggestions. Just let me know. Let's see, any suggestions? Okay, I'm going to click on over to the Knowledge Fellowship. Thank you for the bits, Veronica Cure. Thank you so much. Let's see who's live. Oh, Bother is live. Let's go raid Bother. So enjoy your nap, Fenring. Enjoy your nap. So please give Bother a warm CosmoQuest welcome. And wherever you are in the world, have a fabulous morning, evening, or afternoon. And remember to get outside and look up. And if it's gross outside, go online and help us map Bennu. I'll see you all on the other side. Bye-bye.